It's finally here! It's the machine I'm not embarrassed to show my friends anymore. This is Prusa's latest 3D printer, the Prusa CORE One, where they finally put their proven hardware into an enclosure that not only looks great, but also finally offers enthusiasts this compact CoreXY machine that so many have been waiting for. But is it too little too late with all the competitors on the market these days? Or can it deliver in terms of specs, quality and reliability? Let's find out more. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. I've basically waited for this machine for the last 2 years and regularly begged Joe Prusa to take one of their CoreXY print farm machines, put it into an enclosure and sell it. They didn't exactly do that. But around a week ago, this box finally arrived. I want to be transparent here, and you might be seeing two different CORE Ones in this video. The courier heavily mistreated the initial review unit that I got, and Prusa swiftly replaced it with a new one. So today, if you're watching this on January 31st, the review embargo dropped, Prusa starts shipping the assembled printers and opens orders for the CORE One kit you need to assemble yourself, and even the upgrade kit, which can convert your Mark 4S into a fully fledged CORE One. Prusa usually has a long wait list, so if you plan to order one, then watch what my experience was with it and order quickly. An affiliate link that helps me in what I love doing is down in the description. So the CORE One is a heavy beast, and if you don't want to hurt your back, then have somebody help you set it up. After opening the box and removing the steel sheet, some small accessories, the gummy bears and a full spool of Prusa PLA, the machine can be lifted and placed on the table. The cardboard sleeve is quickly removed, revealing another accessory box on the right side of the machine, which contains the screen. This is the only thing that needs to be assembled on the CORE One. You have to attach a grounding cable and plug in a ribbon cable, which is a bit fiddly. You do this when the machine is on its side and attach everything with 2 screws to a magnetically attached panel so that you don't easily break the screen if you tilt the machine afterwards. After removing a bit of cardboard that keeps the motion system in place during shipping, you're ready to turn the unit on. Similar to Prusa's XL and the Mark IV, a wizard guides you through the initial setup. The CORE One can operate completely offline, but you can connect it to your local network. The great thing is that the touchscreen is finally functional, which allows you to enter your credentials. You can also use the Prusa app to type them on your phone and transfer everything via an NFC reader located in the back of the machine. If you wish, and this is optional, you can then connect the printer to Prusa Connect, which is their cloud-based printer and print farm management software. I only recently found out that this is really good, and we'll discuss it later. Once this is done, the machine performs some self-test and makes sure that everything works. You assisted in ensuring that the load cell in the hot end is functional by tapping on it, and after about 10 minutes the CORE One is ready for printing. I also installed the optional chamber camera available for $40, which is simply mounted by magnets to the upper left corner and powered by a pre-installed USB cable. This camera only works if you're using Prusa Connect and connects to Wi-Fi and the cloud by scanning a QR code generated within the Prusa app. Let's quickly do a first print before we examine the full specs of the machine. I loaded some of the Galaxy Black Prusa mend that came with the CORE One and printed the first 3D Banshee, which I quickly sliced in Prusa Slicer and wirelessly sent it to the machine with just 2 clicks in Prusa Connect. The CORE One uses a really well-working nozzle probing system. It features a load cell in the print head to accurately measure the build surface, meaning no Z compensation is necessary regardless of the build plate that you're using, and you'll always get this perfect first layer. To save time, it only probes the area where the print later will take place, and after a bit of purging, it starts extruding the plastic. The Banshee with default settings took 37 minutes to finish, as displayed in time left and in real time on the screen. Based on my experience with the Mark IV and XL, this is usually very accurate, making it very easy to plan prints and start new ones. Prusa machines used to be really silent during operation, especially the Mark III. However, with faster print speeds, there's now a noticeable motor noise during printing, alongside the more powerful cooling and venting system needed to quickly solidify the large amounts of plastic. The enclosure helps reduce the noise a bit, but it's still noticeable, although I might be picky here. When it's not running, it's perfectly quiet though. The Banshee came out looking great with hardly any artifacts at first sight. I've printed way more models during my test, and we'll have a detailed look at them later. How these results compare to other machines is something we'll explore as well, as I printed the same parts in the same material on the CORE One, the Mark IV, the Mark III's and the Bambu Lab X1, and I'll conduct a blind comparison with my 2 studio colleagues. Since we know that it's working now, let's discuss the specs. The Core One is an enclosed machine with a slightly smaller footprint than the Mark IV, eliminating the moving bed, utilizing a fast, rigid CoreXY kinematic system. Weighing over 22 kilograms, it's very heavy, largely due to its sturdy sheet metal construction. I must admit the machine looks fantastic, with the black exterior and the characteristic orange accents that make Prusa machines so recognizable. The LED strip under the bed is also eye-catching and indicates whether the printer is in idle, printing, has a warning, or even an error. It might seem like a gimmick if you just have one machine, but it's awesome in a farm setting. The entire enclosure is made from thin sheet metal that's precisely cut and bent, resembling their other enclosures. It doesn't look cheap at all, featuring precise gaps and a really nice matte finish. Even the pockets on the side are made from sheet metal, which not only stiffens the frame, but also reduces the internal volume, allowing it to heat up faster and enabling you to load filament from the side, which is really convenient. The other side pocket gives you space to mount your equipment with printable mods. Speaking of mounting, Prusa also sent me this fish right here, though I honestly have no idea what it's for. Since it's plastic and has magnets on the back, it might be intended to showcase how you can customize your machine with magnetic mods, like this fish, since the enclosure is steel. But now back to more serious matters. All the see-through panels appear to be acrylic, so you should be careful when cleaning them, as they will scratch easily. Since I don't have compressed air right here and the canned stuff is nasty, I recently found my new favorite shop toy, an electric duster. That's perfect to clean the dust from the machine. Link below if you want to get one as well. The door hinges on the left and can easily be flipped to the right if your workspace requires it. The top panel features vents that can be open and closed to adjust airflow, depending on whether you want it hot or cold on the inside. It's a nice touch, but during my tests I sometimes forgot to set it to the right position, so an indicator would be helpful. The acrylic panels are all fastened with those removable yet single-use rivets, which make opening panels for maintenance a bit of a hassle, and I'd like to see a different solution here. Screen cover and door hinges are now injection molded, whereas most of the internal parts are still 3D printed but look much better than on their old machines. They also moved away from PETG prints that regularly failed in warmer areas and now print everything in their carbon fiber PC blend. Personally, I don't mind this at all. On the one hand, you don't notice it if you're not aware, and on the other hand, it allows them to iterate quickly, significantly reduce molding costs, and rigorously test their own printers and materials in their farm. Let's now move to the motion system, where the frame everything is mounted on is also made from rigid steel. The Core One uses a linear rail for the x-axis and linear rods for the y-axis. The z-axis is driven by 3 individual stepper motors, which should allow for 3-point tilt leveling, even though I'm not sure if that's a feature yet. Despite having a different motion system and form factor to the Mark IV, the Core One still utilizes the same build plates, which is great because there's already a large ecosystem with various types for all applications. The build plate is DC powered and can be heated up to 115 degrees, even though their website says 120 degrees Celsius, which is strange. They managed to squeeze out 30% more print volume with 10mm additional on the y-axis and 50mm more on the z-axis compared to the Mark series of their printers. This provides you with a larger print volume than, for example, the Creality K1, but slightly smaller than the one of the Bambu Lab X1. The print head, which is sturdily mounted on the linear rail with an aluminum adapter plate, is very similar to what we already know from the Mark IV and the XL, featuring the Nextruder's large gear feeder where practically no filament slips due to the immense area where it's pressed against the wheel. The hot end, which can reach temperatures up to 290 degrees Celsius, which uses the same proprietary nozzle system, where changing nozzles is relatively simply by loosening 2 grub screws on the side and then unscrewing the nozzle assembly with a provided tool, all while everything is cool. You install everything back in reverse, and since no material can leak, hot tightening isn't necessary anymore. The stock Core One comes equipped with a 0.4mm brass CHT nozzle to optimize printing speeds, which won't allow you to print reinforced materials unless you invest in a hardened steel nozzle. I'm a bit torn here. I would have preferred to see a hardened nozzle right from the start, along with all of the downsides that come with it, to enable the Core One to print every material without having to invest in an extra nozzle right from the start. I mean, on many or even most other printers, this is standard these days, and they managed to make it work as well. But let me know your thoughts below. Would you rather have a fast and easy to use brass nozzle or a slightly slower ball-around nozzle on such a machine? For cooling, they use a large radial fan on the tool head without any additional auxiliary cooling fans. In the back there are 2 exhaust fans. Their speed is automatically set depending on the print chamber temperature that is required. For materials like ABS, ASA and polycarbonate, they are off. For PLA, PETG and TPU, they are adjusted to keep the internal temperature between 20 and 30 degrees Celsius to avoid heat creep and improve cooling. The machine doesn't come with an air filtration system by default, but a professional option will be available soon. Since they utilize 2 small high static pressure axial fans, I'm sure there'll also be quickly HEPA and charcoal filter mods available to download and print yourself. A quick interruption here, there's no sponsor on this video, so if you're convinced that the Prusa CORE One is the machine that you've been waiting for all these years, I would greatly appreciate if you use my affiliate link in the description. If it's not automatically filled out, please use coupon code CNCKitchen at checkout so they know who sent you. This doesn't cost you any cent more, but it helps us creators continue our work, which also made this move into my new studio possible, for example. If the Core One isn't something you're interested in, you can still help us out by visiting our online shop at cnckitchen.store, where you can get the best lead-free heatset inserts to enhance your 3D printing designs, which are now also available in UN sizes. We also just launched our super convenient insert remover and our nozzle poker set made from highly durable piano wire. Check out our products at cnckitchen.store. Before we take a look at more print results and conduct a blind comparison with my studio colleagues, let's talk about Prusa's ecosystem, which is definitely one of the strong points if you buy a Prusa machine. First of all, you're not forced to use Prusa's ecosystem, but it definitely makes things easier if you do. If you've ever used a Prusa machine, you'll find it really easy to prepare models and produce quality prints because of Prusa Slicer. With its material and print profiles, I rarely need to adjust any settings, and if I'm not using Prusa, I usually just select the generic profiles and tweak the printing temperature if the default values differ significantly from the ones on the spool. And this is of course the same with the Core One, because Prusa's goal has always been to ensure that the machines serve you as a tool and not as your project. In the past, I sent all my print jobs to the machine via Prusa Link, which basically provides a direct network connection between the slicer and the printer in your local network. Just a few weeks ago, I started using Prusa Connect, Prusa's cloud-based print and printer management suite, and I genuinely love it. Once you add your machine to Prusa Connect, including the Mini, the Mark IV, the XL, and now the Core One, you can completely manage and control it from the browser and your phone app. Receive notification when prints finish or if problems occur. This tool is incredibly powerful, especially if you have more than just one machine. It allows you to manage an entire print farm, including print queues, statistics, and more. If you connect a camera to your printer, it will also display the camera feed surprisingly low rate at 0.1 frames per second. Yes, this is somewhat disappointing, as one image every 10 seconds feels very outdated, but I've heard they're working on this. When this initially launched, the experience with Prusa Connect was a bit mixed, but they've invested heavily in this platform and I would now consider it a standout feature. Even though there's still many features missing, I would like to record time lapses or have something like cancel object. Anyways, what I wanted to convey is that Prusa has a well-working ecosystem for beginners and even experts who manage a whole print farm. I've printed many models in different materials over the past few days, and since I'm not alone in the studio anymore, I thought it would be fun to make a blind comparison between different printers to find out how the Core One stacks up against the Prusa Mark III, the Mark IVS and the Bambu Lab X1C. I'm now in a shared studio with Marius Hornberger, who's creating woodworking and metalworking videos and uses 3D printers lots in his projects. Reiter is our all-around guy with a focus on electronics and software development. He runs his own print farm where he produces the parts for his pixel pump. Both are very familiar with 3D printing and know what to look out for. For the tests, I chose the 3D Banshee printed in white Prusa Mint, my Mini-Me printed in grey voxel PLA, the Voron Cube printed in green Prusa Mint, and finally the Clock Spring Torture Toaster in orange Prusa Mint. All the parts were printed using the default PLA settings and a 0.2mm layer height. I started and realized that rating parts with different features isn't super easy, so in the end I always had to choose the one that looked the best overall. Next came Marius and finally Robin, both whom faced similar challenges. In the end we were all able to rate them from 1 as the best looking to 4 or 5 as the worst. So the smallest bar in the following graphs will represent the best result. Let's start with the Voron Cube, where the old Mark III won, closely followed by the Mark IVS, with the Core One and X1 Carbon in last place. Interestingly, with the Mini-Me, it was the other way round. Every one of us voted that the Mark III was the worst, especially due to its surface texture. The Mark IVS came in third, then the Core One, and we all concluded that the X1 Carbon looked the best because it printed the smoothest. The Banshee was all over the place because for once the white PLA made it really hard to judge surfaces. It had so many features that you always found both good and bad aspects in one print. Generally, the X1 Carbon came last, the Mark III and the CORE One were second, and the Mark IVS scored the best. The Torture Toaster was again more conclusive, with the X1C rated the best by everyone due to its smooth surfaces, nice details and good overhangs. The X1C's tendency to print with a matte texture could cover some imperfections. The Mark III came second because it also printed very consistently and its slower speed allowed for good overhangs. The Mark IVS came third and the CORE One was last, mainly because its overhang performance was lacking a bit. You can already see that depending on the part and the material used, the perception of print quality can vary. But I also have to say that the print quality of the contestants was sometimes really close and generally at a good level. Still, I wouldn't have expected that the Mark III performed so well, especially because all of its print had this slightly rough texture. However, its slowness, is that a word? Enables it to produce nice overhangs and details. However, this also means that the print results of the CORE One are not perfect. Don't get me wrong, the differences were sometimes really small and nitpicky, but there are some things I could notice on the models that can't be denied. All of my CORE One prints had a slightly rough surface and some tiny layer inconsistencies. Again, you can only see this if you really look closely, especially when comparing it to other prints. But there is something. On the other hand, the Bambu Lab prints also have this slight salmon skin effect on them, which you can also only notice on smooth curved surfaces. I'm not sure what the reason for the imperfections on the CORE One is, but they could be a result of a too stiff motion system where every unevenness is transferred to the model and nothing is dampened by flexibility. Maybe it's the input shaper which uses factory settings and isn't retuned before every print. But I'll be definitely looking into this. So, just to clarify here, the print quality is good. As you can see on the other prints that I made, it's just not perfect, yet still better than what most other machines can probably do out of the box at this speed. The other issue with the CORE One prints was the poorer overhang performance compared to the Mark IVS, for instance. I believe this is simply due to the enclosure getting warmer on the inside than the ambient air that open air printers can use for cooling. Prusa heavily advertised this active chamber temperature management of their new machines, but even though the target temperature was set to 20 degrees for PLA, and with open vents, the temperature within the chamber quickly rose to nearly 30 degrees Celsius. I understand you can't go below ambient, but my studio hovered around 20 degrees Celsius and the chamber fans weren't running at full power. Whether this is an intended feature or a firmware bug is something I'm uncertain about, but I think this elevated temperature reduces cooling performance on overhangs. We can also observe this by comparing the minimal layer times in the slicer of the Mark IVS and the CORE One, where the enclosed machine decreases speed sooner as the open Mark IVS. Interestingly, this also affects printing times, where on small and high prints the Mark IVS is slightly faster than the CORE One. With higher layer times, the CoreXY kinematics can show its benefits and print faster, at least for PLA. This is still not catastrophic and rather nitpicky in comparison to other machines. However, this is something you should consider if you primarily print with PLA. This situation is no different from other enclosed printers, which suggest opening the top and door when printing PLA. Prusa's active temperature management approach is clever and innovative, but this convenient method will also have drawbacks. On the other hand, I always print my PLA at home in an enclosed X1 Carbon at temperatures often exceeding 30 degrees Celsius. And even though this might have some drawbacks on quality, I feel that similar to other high temperature materials, this might even enhance layer adhesion on PLA. Maybe it's worth testing at some point, or what do you think? This serves as a great transition to why I'm so excited about this new form factor and its benefits when working with higher technical materials. Even though I mainly print with PLA, I also strongly advocate for enclosed printers if you're using ABS, ASA or polycarbonate. Enclosures not only trap harmful fumes more efficiently, but they also significantly improve part performance and printability. Prusa had their enclosure, but due to its large size, it never warmed up enough to really enhance part strength, as the heat dissipated across the large surface area faster than it was generated by the bed. The CORE One now features a compact enclosure and efficient heat management that works really well. In Prusa Slicer, you now have a chamber temperature setting with your filament options. The nominal setting is intended for materials that shouldn't be printed too hot, controlling the chamber fan speed to prevent exceeding this temperature. Minimal is particularly interesting for technical materials. When you set this value, the CORE One will pause to preheat the chamber with its bed on at full blast. This will of course delay the start of the print, but it ensures a good print quality and layer adhesion from the very first layer. If you're in a hurry, you can always cancel that routine. This process works really well because the print results with technical materials are great, and layer adhesion is not an issue at all. A very common problem with other open-style machines. Generally speaking, from my test, the Core One performed really well with a variety of materials, from PLA and PETG to flexibles, up to ASA polycarbonate and even carbon fiber reinforced PC blend. The last thing we need to discuss is price. The Core One is not a cheap machine. The fully assembled version, as I have it, costs $1,200 plus potential sales tax. The kit version you can now also order is $250 less expensive. Additionally, if you already own a Mark IVS, you can upgrade it to a Core One with a $450 upgrade kit. As you can see, their machine comes with a premium price tag, costing as much as a Bambolab X1C currently sells for. And this is obviously their biggest competition right now. Just as Prusa, Bambolab has managed to create a well-working ecosystem around their machine that works great and even enables beginners to use their machines without having printed a single part before. So why should you spend $1,200 on a Prusa instead of one from the competition? Trust me, this is a controversial discussion. First of all, let's discuss the price. Prusa machines are manufactured in the European Union, and they've even started building the first machines in the United States. Manufacturing here is simply more expensive than in China, and I won't delve into the details about subsidies in the PRC. This means that their machines will always be pricier than the ones from China, but it's still impressive that Prusa has managed to reduce the cost of the Core One to roughly the same level as the X1 Carbon, which competes in the same category. Next, creating a printer involves more than just sourcing the parts and assembling them. Prusa has invested significantly over the last decade in developing new products rather than merely cloning existing hardware. Lastly, one of the underestimated aspects is software, which includes the printer firmware and especially slicer. We've all become accustomed to using great slicers, and notably the most popular ones right now, Bambolab and Orca Slicer, are heavily based on Prusa Slicer, and it's their fair right. Since all of them are open source, this also created a beneficial ecosystem where new and proven features from one are often rapidly incorporated into the other ones as well. Still, Prusa has laid much of the groundwork over the last few years and vastly enhanced the performance and features coming from Alessandro Ranelucci with Slick 3R. What I mean by that is that software engineers are costly, and when you purchase a Prusa, you're not only paying for hardware, but also the software that allows their printers to operate so smoothly. Developing a slicer is simply more expensive than reskinning an existing one. Still, some might refer to this as the Prusa tax, while others see this as an investment in a robust and evolving software and hardware ecosystem, which everyone benefits from. Prusa machines, despite some rough starts, have been solid and reliable workhorses for many years. This is one of the reasons why they are so popular in print farms, next to Prusa's file management system and the fact that most parts are off the shelf and fully disassemblable, making them easy to repair and maintain. Additionally, Prusa has consistently provided software and feature updates for many years. In fact, the Prusa Mark III received a new firmware less than 2 months ago, even though it's over 7 years old. Privacy and security are also key focuses from Prusa. Your machines don't need to be connected to a network or the internet. Firmware updates can typically be done via a USB drive, which can be crucial if you use 3D printing for your business. This may sound like a lot of fanboy enthusiasm, but trust me, the 3D printing world wouldn't be as remarkable without Prusa and their open source software, community spirit, and the strong community they've built over the years. Don't get me wrong, we also owe the existence of the Core One, mainstream fast 3D printing, and effective multicolor systems to Bambolab. However, no one wants a 3D printing monopoly, as that would be harmful to consumers and innovation. Prusa has proven to be a trustworthy company with genuine customer support. They provide a flawless printing experience, heavily invest in the community, and maintain a passion for the technology, making them a solid choice. You may pay more, but you gain convenience and invest in the progress of additive manufacturing that is accessible to everyone. Still, they have their own issues, and not everyone can pay this amount of money for a 3D printer. So inform yourself what your requirements are and spend your money accordingly. So let's quickly summarize this long video. I think the Core One was long overdue and Prusa finally delivered what everyone wanted. I adore its looks with the dark enclosure and the tinted panels and the nice color accents. It's fast, and with the enclosure and heat management, it's finally versatile and can properly print all the materials a hobbyist and prosumer usually needs, from flexible to stiff reinforced materials. PLA performance is good, but in my opinion, it slightly suffers from the enclosure. However, this machine shines especially for materials used in functional prints. Even though it doesn't come at a beginner's price, it's genuinely super beginner friendly because it's set up in 10 minutes and comes with a well-functioning ecosystem that doesn't require you to tinker around with profiles. Prusa Connect though optional, is not only great for managing and monitoring your prints through the cloud, but also allows for full farm management if you have more than one Prusa machine. Unfortunately, even though the assembled machine costs $1,200 excluding tax, it doesn't include some accessories we have gotten used to with other machines. A camera costs $40, an accelerometer $18, an air filter will be $76, and a hardened steel nozzle, which you'll need if you want to print with carbon fiber materials, starts at $53. But at this price, you're investing in an ecosystem where Prusa has shown over the years that they'll keep supporting and improving it, and if hardware revisions arrive, there's usually a reasonably priced upgrade path to get the new features. The release still feels a bit rushed, and it will require a bit more polish with upcoming firmware and slicer releases. The good thing is, if you order now, you won't be getting your machine before the spring, where the early adopter problems will hopefully have already been figured out. Link below. So the Prusa CORE One is a printer I'm no longer embarrassed to show my friends, despite all of the competition in the market. Don't get me wrong, the Prusa Mark IV was and still is a very good printer, but it's utilitarian. It works great, but it looks a bit like a student project these days. The Prusa CORE One brings back that appeal they've been missing ever since they decided not to jump on the bandwagon and emulate what worked so well for Bambu Lab when they launched the X1. So this change in mindset is great. This restores my faith in Prusa because the CORE One is what I wanted to see from them for so long. It is already good, I'm sure it will get even better with time, and I think it will help Prusa become more competitive in the 3D printer market again, not just for the fanboys. So this is where we are. I'd love to get your thoughts on the Prusa CORE One. Do you think it really has a place in this market? Does it fill the gap that needed to be filled in the Prusa lineup? Or do you think it's completely obsolete at this price point? Share your thoughts in the comments. Thanks for watching everyone. I hope you found this video interesting. If you want to support my work, head over to Patreon or become a YouTube member. Also check out the other videos in my library. I hope to see you in the next one. Auf Wiedersehen and goodbye. Smooth curved surfaces.